Hey, a very warm welcome, everyone. Welcome to our today's discussion on K-means clustering with a discussion on the project of customer segmentation with Mr. Pranav Jaipurkar. Mr. Pranav is a data scientist at Zidali, and he has been working on a lot of. Hey, a very warm welcome, everyone. Welcome to our. So he has been working on data science, practically implementing a lot of concepts. And today we will be having a discussion with him on K-means clustering, where he might be discussing the projects on customer segmentation. And finally, the whole agenda of organizing this program is we are coming up with a full-fledged course with Pranav Jaipurkar in December onwards, so that you can learn industrial level data science and machine learning with Pranav himself. So guys, I want to introduce Pranav officially. So what are we going to have today? Allow me a couple of minutes. Yes. So here. So we will be having this discussion on K-means clustering with Mr. Pranav, data scientist at Zidali. Zidali is an AI integrated predictive and prescriptive intelligence solutions company. This session, we are organizing it live on Zoom from 5 p.m. to 6 p.m. today, 10th December. Somehow, if any of the students who miss the session, they will have access to the recording so that they can view the recording and they can join Pranav's session in future when we are organizing it in December onwards, and in future, whatever the number of sessions will be organized. So coming to Pranav's profile, Pranav, I would request you to share a few, highlights about the experience you had working as a data scientist in the industry, and what are the kind of challenges you have, taken up and sorted during your industrial experience. So a very warm welcome, Pranav. Over to you.
Yeah, sure. So guys, actually, if you see my LinkedIn profile and if you see about my journey from my academic background to being a data scientist in industry, so everyone knows right now that I'm working as a data scientist in one of the companies, but I have completed my bachelor's in electrical engineering from College of Engineering, Pune from 2014 to 18. And the only relevant part from my complete bachelor's profile directly allied to my job today is my final year project. So actually what I did in that particular part is I tried to create a predictive algorithm that could give you some estimation about the amount of solar energy that will be generated tomorrow. So the only problem in harnessing solar energy right now is that it is not reliable. So if you have 100 kilowatts of power today from a certain system of solar PV panels, you are not sure how much energy you can probably have tomorrow. So we all know that there is a great shortage of coal in India, and at some other level, we will have to shift from the traditional methods of building energy to renewable energy. And I think solar energy is one of the most preferred technologies for that. So I logged in. See, I had domain knowledge about the problem, and actually I wanted to like increase the reliability of that particular system. Then after that, I got an admit in University of Maryland College Park for electrical and computer engineering with a minor in data science. So I got most of my academic background in data science, whether it is SQL Server, database management, API, front end, data science, data wrangling, deep learning, computer vision. There are a lot of topics that come in analytics domain. So when you will start learning data science and data analytics, you will come to know that there are different branches of this particular field. So if you go on LinkedIn, if you search for jobs at this particular moment, you will see that there are natural language processing engineers coming up, there are computer vision engineers coming up, there is risk analytics, marketing segmentation, customer segmentation, then anomaly detection, fraud detections. So there are many applications, and more specifically there are many specific applications of this particular technology. So I have worked on a lot of things after my master's degree was over. I initially worked at Ugam Solutions as a SQL developer, where I was handling the data pipelining part for my complete team. So the data was flowing from client end to the SFTP server, if you are not aware of that. That is completely fine at this moment. Then from there, it was going to the SQL Server database. From there, data scientists were accessing the tables and they were doing some predictive modeling on the data that they extracted from SQL Server database. Then the predictions of that machine learning model were getting stored in some other table in the same database. And from there, it was connected to the front end website through API. So this is the complete data architecture of the team that we had. So there are a lot of things actually to know in this particular field. The first and the foremost part that you should know is domain knowledge. Then the next part is about some
कैसे
coding.
करते हैं?
Yeah, Sejal, hi. I think, yeah. So actually, there are a lot, as I was saying, there are a lot of things that are there in this particular field of data science and data analytics, right from getting the data from real world to uploading and deploying it into production. So many courses online that are available teach you about data science, teach you about machine learning, the basic ML algorithms. But my particular aim in teaching data science to beginners is that they should be able to learn end-to-end model deployment. Like you should also be able to put that model into production. Otherwise, there is no use because nobody will be able to use the computational intelligence that your model is having unless and until you put that into production. So there are a lot of challenges. I am definitely sure that I cannot tell you all the challenges in one particular session. But if all of you guys are fine, we can begin with the k-means clustering demo session. It has customer segmentation, which is a very blooming field right now. If you search on LinkedIn, there are many jobs available in customer segmentation, marketing segmentation arena, and I want all of you guys to really update me. If you want to interact with me on certain part, you can do that right now, and then we will complete the session. Because if we go into the session will take complete time up till 6 p.m., whether we start it right now or 10 minutes later. So if you have any questions to discuss with me, you can discuss it right now. And once they are done, we can then move to the discussion part.
Yeah, guys. So if you have any questions, you can feel free to speak to Pranav during the session. And Pranav will be walking us through the theoretical concepts along with how we can practically implement it. So feel free to implement what Pranav is teaching us today. And in the meantime, you are going to get a glimpse of how Pranav teaches and the kind of concept he has brought for us today in the discussion, followed by in the program. When we are going to take up the program, he will be taking care of walking us through the basic concepts as well as taking us to the advanced concepts with practical implementations of projects. So I'm going to discuss about the program details at the end of the program. So and at the moment we'll be having this practically, so feel free to interact with Pranav. And if you have any kind of questions in data science, deep learning, machine learning, feel free to speak to us.
Uh, exactly uh, as the
Yeah,
so
and Pranav, you can continue with the session. In case if they have any questions, they'll be speaking with us in the meantime.
okay, sure. That's also a perfect plan. Or else what we can do is I will, after every 5 to 7 minutes, I will ask you if you have any doubts. At that point of time, you guys can unmute your mic and update me so that my link is not broken. That is also a very important part.
Absolutely, absolutely.
Yeah. So k-means clustering is one of the very popular machine learning algorithms used in real world scenarios even today. So there are a lot of concepts. This is one of the mediocre or intermediate machine learning algorithms. So you need to have some basic idea about machine learning, some basic idea about data science. But I will try to walk you through each and every lecture slide present. And then I have a live coded file prepared for you guys, because if we want to implement it, it will take 1 to 1.5 hours after that. So provided that we have a limited amount of 45 minutes, I will try to explain you all the major concepts. So yes, what is clustering? The first, forget about key means, forget about everything. Just focus on the word clustering. What is the meaning of this word clustering? So basically, if you do a scatter plot with one feature in your input data on x-axis and another feature of your input data on y-axis, and you get a figure which looks something like this on the screen. So by common sense, all of you guys can tell that there are four groups that you can identify. So this is one group, this is one group, this is another, and this is the last one. So there are four different groups visible by our naked eye. So since they are really different from each other, there is a huge separation between the group of data points. You can see that there are four groups or four clusters available in your data set. And that is what is meant by clustering. It is basically the task of dividing the population or the data points into different number of groups which is specified by the user, such that data points in one particular group are similar to each other. Like all the data points that are within this particular cluster are having similar characteristics. And on the other hand, data points from the first cluster and second cluster are having really different properties from each other. So this is what is meant for this particular third and fourth and fifth line. So groups such that the data points in the same groups are more similar to the other data points and in the same group and is similar to the data points from other groups. And the main reason for this is that if you start working in any corporate organization, they have different business strategies, they have different business plans available, they have some promotional offers available. So depending upon the customer segmentation, the machine learning algorithm on its own is altering the offers that are available. So in Amazon, if you are a new customer, obviously on the Amazon app, they will try to make sure that they are retaining you as a customer. So more offers will be given to you. Then if you are an old customer, they will study the pattern, study the domains from which you are buying products. Are you buying more electronic products, more grocery products? And there is a lot of complex algorithms which run at the back end. And clustering is basically reducing the task of making too many business decisions, and it is actually boosting the task of making sorted decisions for a smaller subspace or subgroups of sample points. Then after this part, the next thing is, what does k-mean clustering do for you? So suppose this x1 on x-axis is one input feature, x2 on y-axis is another input feature. So before k-means clustering, this is the scatter plot that you are getting. And after you apply k-means algorithm on this particular data point, you will get these groups. So this is one group, this is another group, and this is another group. So now many of you might have some questions why only three groups are identified. So the number of groups that you want to create from the dataset is completely dependent on you. It is the user or it is the data scientist who will specify the number of clusters, and k means clustering. The value k is actually the number of clusters. The second one means actually means that you will have a median value for the you will have a mean value for the center of the cluster. So basically what happens in k-means clustering is that you divide the data points into the cluster available, and once you have that particular cluster available, you take the mean of data points on x-axis, mean of data points on y-axis, and then you have the centroid. So basically the centroid in k-means clustering is the central point, whereas the centroid in k-medioids clustering is the middle point. So one of the most prominent questions that many interviewers ask me, or they have asked me in previous interviews, is what is the difference between k-means clustering and k-medioids clustering? So if you guys are into this particular course curriculum, one of the tasks that you can always do is, in my class, just make a list of questions. So by the end of the curriculum, you will have a lot of questions. If you prepare those many questions itself for the interview, I think you are good to go. So the difference in k-means and k-medioids, as I told you, is that the centroid in k-medioids is actually one of the data points from the cluster, whereas in k-means clustering, it may be a data point from the cluster or it may not be a data point from the cluster. Okay, so any doubts by any one of you up till now? You can unmute your mic and let me know.
Pranav, I was just figuring out, let's say, when it comes to clustering, it's a very important topic, and I believe it is used a lot in the industry on various cases. I just want, a little explanation if you can just put a light. Let's say if, let's say I'm a Pizza Hut or a McDonald's store, okay? And
Okay.
I want to, deploy a few outlets in the city, suppose on the basis of a map or on the basis of a region. So I have heard somewhere that we can make use of cluster in order to identify the kind of current outlets available, and then we can place the new outlet at a specific position using k-means like that. So if you can just walk us through, how we can how we can pick up a K point, and then how we can quickly put the points and make that cluster accordingly.
Okay, so actually what happens in that particular problem statement is that if you have an outlet in a particular location, then the researchers at a particular company, for example, McDonald's, KFC, whatever food franchise you're using, they have certain radius within which all the people will come to their store. So if you want to have a KFC sandwich, or if you want to have a McD burger, you will go to your nearest outlet. So actually what they do is they don't do marketing segmentation for that particular part, but they really divide the complete geographical location in terms of locations which are not getting captured by the current outlets. So for example, they have certain clauses like you cannot actually open another outlet within 3 kilometers or something like that. Another part is they get an idea about the total human population from the maps. So Google Maps is giving you an idea about whether there is a dense traffic in this particular route or not. So in the similar way, they have an idea about what is the proportion of footfall in a particular location. So that is something that I think answers your question, right?
Yes, Pranav, exactly. Thank
Yeah.
you.
So I think we can begin with the next slide. So how does it work? So there are actually, this is the flow chart. When you will start implementing k-means clustering algorithm, it is a 5-step job, but you don't have to perform these 5 steps explicitly. You just have to import a function. You have a library available in Python. You just have to import the function, and that function will do these 5 steps for you. But what happens is, if you want to work as a data scientist, you should know how each and every function is working, how each and every command is working. So basically, you have to first specify the number of clusters key that you want. So if you want 4 groups out of your data set, if you want 3 groups out of your data set, you have to specify the number of clusters key at the beginning. Then the second step is you actually have to choose k random points, which will be the centroids or middle points of your data set. And the random point selection part is something that you might have doubts. So I have a very good interactive session slides for that. Once you have those key random points, which are centers of those key clusters, you calculate the distance of every data point from all the k points or k cluster centers actually. And the data point which is closest to set to any centroid, it is assigned to that particular cluster. Then you compute and place the new centroid. Basically, you take the average of all data points on x and y axis, you shift the position of centroid, and again do the same part. If there is no change in the position of certain classes of clusters, then you finish the model. And if there is change in position of some data points, that earlier a data point was belonging to cluster 1, now it is belonging to cluster 2, you repeat this process. So rather than reading this part, let us go into the theoretical part. So suppose that this is the scatter plot, and you want to have 2 clusters for this particular scatter plot. So the first step is completed. You have chosen the number of clusters key that you want, which is 2. Now the step 2 is you have to randomly select key points, which will be the centroids or center points of your clusters. So randomly I select this red colored square blocks as one of the center, and blue colored square box as the second cluster center. Okay, now the part is for every point here available, I will calculate the distance from this centroid as well as from this centroid. So if we take this particular point, it is closer to the red colored centroid than to the blue colored centroid, if I'm not wrong. So this point will get assigned to red colored cluster. Similarly for this, but this will get assigned to blue colored clusters. And similarly, you will do the initial cluster allocation for the complete dataset points. So any doubts up till this point by anyone?
Guys, anybody, any questions? Feel free to ask your questions. I believe we can continue, Pranav.
Yeah. Now the next part is assign each data points to the closest centroid, which I was saying. So you see that this is the best hyperplane, and these are the points which will be allocated to the red colored cluster. And this second part is something that will get allocated to blue colored cluster. So is this point clear? I am asking again and again because this is the most important part. So this is the initial cluster allocation. Step 3 is completed. Any doubts here? So I think I can continue with the next part. So once this is done, what we do is we take the average of points which were allocated to the red colored cluster along X and Y axis, and we replace or we shift the position of centroid. So basically when you take the average on X and Y coordinates, you will shift it to this location and this will get shifted to this location. So since there is a change in position of the centroid now, what essentially happens is you again recalculate all the distances for all the scatter points from both centroids, since there is a change in position of centroid. And if there is change, so this point was earlier belonging to the red colored category, and even after change in position of centroid, it is belonging to red colored category only. But there might be some data points which will be allocated to a different cluster after the change in position of centroid. So if there is a change in position, change in cluster allocation for some data points, or if there is a change in cluster position, you have to repeat the step 3 and step 4 iteratively until and unless there is no further change in the position of centroid, as well as no further change in the position of or allocation of clusters to every data point. Otherwise, go to finish. So if there is no reassignment taking place, you finish the model, and these are the optimal clusters and these are the centroids. So this is the finished model. So any doubts, guys, in the conceptual part of k-means clustering? Anyone? Any doubts? The process is clear to everyone because this is what generally interviewers ask in interviews. What is the procedure to allocate clusters and all?
Yeah, Pranav, that's clear.
Yeah, so I think I can move on with the next part. So then there are, so this was the most basic introduction to k-means clustering. Okay, now what happens is there are some things that you need to really take care of while you do the clustering algorithm. The first part that you need to take care of is random initialization trap. So from the previous example that I have demonstrated, all of you must be aware that the initial allocation of centroids is really something that will influence the quality of clusterization. So whatever I have shown you up till now, it was very good initial allocation. So for this data point, if these are the cluster centroids, these are the optimum clusters. Good, we can complete the task. But what will happen if there is a bad random initialization? So suppose this is the scatter plot. These are the bogus centroids that you have identified, and these are the final clusters that are getting identified due to your wrong random selection. So so this is possible, right? This is something that can happen when you are doing clustering. So there is a step or for avoiding this trap, and the solution is called as k-means plus plus. And what happens and what is the underlying terminology behind this k-means plus plus is that the cluster centroids that you select in particular should be at as far away from each other in the feature space as possible. So this is the only solution through which you can avoid this bad random initialization trap. So any doubts in the understanding of trap as well as its solution? So if you select the initial centroid positions which are very far away from each other, it might increase the number of iterations to reach the optimum cluster, but it will avoid getting you trapped in random initialization, bad random initialization actually. So is it clear, guys?
Yes, Pranav. You can
Then
continue. Yeah.
yeah. Then the next part is there is a metric associated in k-means clustering which is called as within cluster sum of squares. So what essentially happens is if all the data points in a particular cluster are closely packed to each other, then this metric value is very less. And if the data points in a cluster are closely packed to each other, it means that they must be exhibiting really similar properties than a cluster in which data points are very sparsely populated. So for the three cluster example that I've shown you earlier, the WCSS value is a summation of all of these three terms. So if Pi is a data point in cluster 1, then summation of square of distance from Pi to C1 for the cluster 1, for C2 or cluster 2 and cluster 3. When you add all these sum of square of distances for all the data points from their respective cluster centers, you get a metric which is WCSS. So is this metric clear to you guys? What is this metric? So the lower is the value of this metric, the better clusterization algorithm you have. Is this part clear, guys? Then the next part is this. So if you have three clusters, WCSS is a summation of three terms here. If you have just a single cluster, this is the ideal centroid and this is the cluster. So suppose that you have a single cluster, you have the WCSS value equal to X. Let us suppose that WCSS value is equal to X when the number of clusters is 1. Then if you have two clusters, these are the optimum two clusters and WCSS value is equal to Y. And suppose you have three clusters and this is the equation and WCSS value is equal to Z. So can any one of you update me what should be the relationship between X, Y and Z? So X is the WCSS value when number of clusters is 1, Y is the WCSS value when number of clusters is 2, and Z is the WCSS value when number of clusters is equal to 3. So there is a definite relationship between X, Y, and Z. I just want any one of you to share what they think about the relationship. So anyone, any update on this? So basically what happens is as you go on increasing the number of clusters from 1 up till a certain range. So suppose you have 100 data points in your scatter plot. So as you go on increasing the number of clusters from 1 onwards, the WCSS value essentially goes on reducing. And when every point becomes a cluster himself, the WCSS value is 0. So if there are 100 data points and you are creating 100 clusters, the WCSS value is equal to 0. And there is a definite method to find the optimal value of number of clusters K. So essentially our aim is not to reduce WCSS, but our aim is to divide the number of data points into optimal groups. So choosing the right number of clusters. So there is a method, statistical method for deciding optimal number of clusters, which is called as elbow method, which is essentially a graph between the distortion score WCSS on y-axis versus k or number of clusters on x-axis. So distortion is measured by WCSS, and depending on the distortion, appropriate number of clusters k is chosen. So for 3 clusters, this is the graph. So when number of clusters was equal to 1, this was the WCSS value. When 2, it was 2, it was this, and when it was 3, it was this. So you see, as the number of clusters is increasing, it is decreasing only. So it is 100% sure that at any point, if you increase the number of clusters, WCSS will decrease only. But our aim, as I told you, is to find optimal number of clusters, which is found out by the elbow point. So from 1 to 2, there is a steep decrease in WCSS value. Similarly, from 2 to 3, there is a steep decrease in WCSS value. But from 3 onwards, what happens is the rate of decrease of WCSS is not significant enough. So this is the right point where we can stop increasing the number of clusters. So the optimal number of clusters from the given point comes out to be equal to 3. This is what I wanted to update, and this is the elbow method. Then the next part is there are definite set of assumptions, advantages, and disadvantages associated with each and every input variable and each and every part of the k-means clustering algorithm. So before I go on with that part, I want to make sure that you guys are really well aware of what we did. So any doubts by anyone wants to discuss anything? So basically what happens is there are 3 assumptions in k-means clustering algorithm. K-means assumes that the variance of distribution of each variable or each input variable is spherical. So if you do a density plot for the variance of distribution, you should get a spherical structure for all the input variables. The variance is same for all input variables. So if you calculate the variance, it should be same. It means that you will have to standardize all the input variables before you feed the data to KNN algorithm. And the prior probability for all the k clusters is same. That is, there is a default in this k-means clustering algorithm which assumes that every cluster should approximately have equal number of observations. Then clusters in k-means are defined by taking the mean of all data points in cluster. Then the advantages are that it is relatively simple to implement. It has a huge scalability advantage as it scales to large data sets. It guarantees convergence. It can warm start the position of centroids, and it can easily adapt to new examples. And it generalizes to clusters of different shapes and sizes, such as elliptical clusters. Disadvantages is that you will have to do hyperparameter optimization. The number of clusters k is the hyperparameter in this algorithm. And through the elbow method, you will have to find the optimal number of clusters, and you will have to specify that at the beginning. K-means can handle only numerical data. Categorical data cannot be grouped using this algorithm. The clusters are dependent on initial values of or initial position of the centroids. Clustering data of varying size and density means that it is not taking into account that there might be some clusters which are less densely populated, and there can be some clusters which are highly dense. Clustering outliers means that k-means clustering is really sensitive to outliers, so you will have to do outlier detection and outlier removal first. Then you will have to standardize the data, and then you will have to feed the processed data to k-means clustering algorithm. And the last part is that it scales with the number of dimensions. And the applications are that it can be used in some of these things which I have mentioned, but not limited to these things. It can be used in marketing arena for marketing segmentation, customer segmentation, and apply optimal methods for getting the utmost publicity for a particular post. Then in biology, it can be used for classification among different species of plants and animals. It can be used for library management. You can group books of similar topic and information in one particular part of a library. And in insurance companies, it can be used to acknowledge the customers that are showing similar behavior, frame similar policies for them, and identify the frauds. So I think the theoretical part for key means clustering is now completed. So any questions by any one of you in any part up till now? So this is a very basic understanding of key means clustering algorithm. Any doubts, Prajwal, Pramod, E? Any doubts by anyone?
Guys, if you have any doubts, please let me know. Prajwal Dwivedi, Pramod Kumar Kushwaha, is my voice audible to you?
Yeah, your voice is audible. Yes.
Okay, great. So, Pramod, Prajwal, can you turn your cams on? Can you let us know in which college or organization you are? Am I audible to you? Okay, anyways, Pranav, we can continue. We can just finish it off.
Yeah. Sure.
We can continue the code part. Yeah.
Yeah. I will
Maybe
straight
the
away.
students are sometimes a little hesitant, in the demos. So that
No,
won't
no,
be
no
an issue.
problem.
We can discuss in
No
continuation.
problem.
Yeah.
No problem. So basically, this is what something looks like. This is called as Jupyter Notebook, and this is an ID specially designed for creating machine learning models. And these things are Jupyter cells. So basically, in the first Jupyter cell, you import all the important libraries available here. I know many of you will not be familiar with many libraries, but I will explain you from the beginning so you will not have to worry about it. So the first, I will just explain the concept behind every block. Okay. So this is where you import all the necessary libraries which have the functions which will do the job for you. So from sklearn.cluster, import key means which will perform key means clustering for you. From sklearn.preprocessing, import standard scaler will do the standard scaling for you. Then importing the data. So I have a malls customer data available in my local computer. I am importing it through the pandas library. And this is how the data looks like. So customer ID, gender, age, income, and spending score. So basically, the mall wanted, there was a competition on Kaggle that the mall wants you to group the customers based on their annual income and spending score. So your data.d types will give you information about different types of data available. Then you apply scaling techniques so that the data is on the same scale on annual income and spending score column using this particular block. After this is done, you make a copy of actual thing because you don't want to mess up with the actual data. And this is the elbow method which I was talking about. So using a for loop, we iterate the value of k, which is the number of clusters in a particular range, and then we store the WCSS value in dictionaries. And then we have a plot for WCSS or distortion on this axis and values of k on this axis. So from this graph, you can see that as the value of k is increasing from 1 to 2, 2 to 3, 3 to 4, and 4 to 5, there is a steep decrease in distortion. And 5 onwards, the decrease is far less. So from this graph, we can infer that the elbow point is 5, and this should be the optimal number of clusters. And the second part is again the same graph but using inertia. So the difference between inertia and distortion is that distortion takes into account the error per data point. So we basically divide it here with the total number of data points that we have, whereas inertia aggregates the total error for every cluster. So distortion basically takes into account that clusters can have different densities, but inertia does not take that. But I am explaining you from both methods. Then using this method, you can also see that there is a steep decrease up till k equal to 5. and the decrease is not significant enough. So from both the graphs of inertia and distortion versus k, we can infer that optimal number of clusters for this particular problem should be 5. And then the last part is pretty simple, that we give the optimal number of clusters as 5 in the k-means function. We fit the data and we do a scatter plot to show what are the clusters. And these are the cluster centers actually. So this green colored part that you see here, sorry, this yellow colored points that you see here are people who have low income on x-axis and low spending score. So basically these are the people who are not having a good income and they are not also spending good income, a good amount of money, sorry. This apparent green color is basically people who don't have income but they spend a lot of money. This middle portion is basically the customers who have medium income and spend in a mediocre fashion. This blue colored or royal blue colored data points are those people who have high income but spend low. And this purple color or brinjal colored data points are the customers who have high income and who spend a lot. And the red colored points are the respective cluster centers. So this is the complete k-means clustering right from scratch at a very basic level. So I know you might have a lot of doubts in this part, but if you start with the basics, it is a really easy algorithm to implement. And do you guys want to discuss anything on this particular part? So any doubts by anyone? So Devanshu, I think you can continue your part. You wanted to address something at the end of the day if they are not having any doubts.
Right. So Pranav, are we done with the content for
Yeah,
the
yeah,
complete?
yeah. Yeah, we are done with the content. Basically, there is a lot more to explain, but
Mhm.
I am not sure about the basic understanding. What basic understanding do all the people have? So I've just given them a high level overview of what we are doing. Once they
Okay.
get to know what is scaling, why do we do scaling and all, probably this session will go for 2 hours. So as we are planning to keep a 2 hour session, this is
Right.
usually a 2 hour session, but because we will live code each and everything.
Absolutely.
Okay,
Absolutely.
so it takes a lot of time at that point of time, but I think they got a brief understanding of how the sessions might look, which
Absolutely.
was our initial plan. So yeah.
Absolutely. Yes. So we have had a high level understanding of the complete code, right? So there's a question from the
Yeah,
student.
yeah. There is a question. No, actually, this is a very good doubt. I did not convert genders to numbers because I wanted to have an overview of the complete data. Now, what you can do is you can have a subset of data based on gender. Like
Right.
you can have you can have separate data frames for male, separate data frame for females, and separate data frame for others, and analyze and do clustering for them. So yeah, you're completely right if you want to discuss that part. So this is how the initial data looks like. So yes, you can do that. That is also a good method, but that is a more in-depth analytical method. So I
Right.
think Devyanshu her doubt is clear. So any
Great.
other doubts are welcome, but you have only 10 minutes now, I think.
Right. So guys, anybody, any questions? Anyone else? Would you like to ask anything? Pranav, can we just scroll down the code a little bit so that people will get to have a little idea of what all others script code is available, right? So then we have the distortions. Okay, I can see that distortions part, the elbow method using distortion. Okay, got it. And we got the elbow method distortion done. This we already discussed on the slides also.
Yes,
Right.
and the elbow method using inertia. These are the only things that will help you to optimize the key means clustering model. Other
Right.
than that, once you get the optimal number of clusters, everything is pretty easy.
Absolutely, absolutely. Perfect. So guys, I believe you had a discussion with Pranav. According to the concept of the day, we had a discussion on how machine learning works and how basically k-means clustering works. So now what we are coming up with a machine learning and a deep learning program in December. One program we are starting from 13th of December, which is Monday, and the second program we are starting somewhere from the next week, which is I think 20th December onward. So these are the two programs which we are coming up on machine learning and deep learning. Coming to the kind of content which we are covering in the program. So in the program, we have specific section for machine learning and deep learning, where we are covering the following algorithms of machine learning and deep learning. So I'll walk you through with the kind of algorithms which we will cover. In the course, what are we having? I think my voice is audible, right? Yeah. So in the course, what are we having? This course will be taught by working in industry professionals, those who are working as data scientists in the industry. So you can expect a complete hands-on implementation, and the kind of concepts which you will be learning are the actually used concept in the industry. So beyond the book level knowledge you're going to get, along with that, whatever training sessions we are covering, you're going to get live recordings as well of the session post live interaction, so that you can access it anytime. You can implement it as per your comfortable time. In case if you miss out any classes, you will get access to it. Along with this, you will get certificates for the course. We have a paid internship and 100% guaranteed placement program associated with this machine learning and deep learning course, where on completion of this 3 months course, you're going to get a 5 month stipend as a paid intern to work on machine learning projects with us, along with a placement of 4 lakhs per annum minimum. So that is what you are going to get. Then what next we have, apart from the machine learning algorithms, this is what will be covered. Then we will be having deep learning concepts covered during the program, where you will be getting, you'll get to know how convolutional layers are made, how pooling layers are made, and how pre-trained models, merging layers, everything works. So this is what we're covering in the course. Currently, the course comes at an online price of 11,800 each, but we are running certain discounts for users. So you might have received an email with a discount offer, which you can claim in order to take it. So the discounts are somewhere from 65% to 70% off, depending on your interactions with Hack With Us platform. You would have received the discount on your emails, so you can claim those discounts. So guys, this is the program which we are coming up on 13th December and 20th December onwards. If you have any questions related to the program, you can speak to me on WhatsApp. And if you have any technical queries, we'll discuss with Pranav and we can sort those queries for you. So Pranav, this is about the program which we are bringing in from 13th December and 20th December onwards. And I will be sharing this information with all the students, those who have joined today. Maybe some of them who might not have joined because the information has been passed very late, due to other occupancies of the programs. But definitely the session recording will be shared with all the participants. So there are approximately more than 3,000 participants, those who have shown interest on intermediate level of machine learning and deep learning concepts to be covered. So we will be rolling out the information, and within a couple of days, the information and the video session will be shared with others. And we will be starting our course from 13th, and the second which we are starting is from 20th December.
Yes.
Right. So guys, thank you so much for coming today. Thank you so much, Pranav, for coming to us, explaining such a nice, concepts of k-means clustering and showing us the industry level, stuff. And one thing which I was really impressed with, Zidali, if you can give us a quick explanation on that also, that would be like, cherry on the cake. So I have seen a few graphs on Zidali's website, and I was pretty impressed with the kind of work, the data science work which is being done. So as I'll just take you there. So I think I have seen some world graph on
Data,
certain data.
world data. Yes, yes.
Yeah, so I'm just going to the site. So guys, you can see that. So that's how a real, data science analytics company works in. So you have internal data of various kind of industries, So if I just make it a little big, I think you all can see that. So now you can see that there is an internal data of the marketing program, sale transactions, project plans, terminal life log, all that data is collected. And followed by that, what comes out, you get to have commodity market analyzed, the price indexes identified, trade indexes identified, interest rates identified. So that's what comes as an output when it comes to data analytics and all. So Zidali is working over the integrated AI part, and there were certain solutions which I was looking into, which I was very happy to see the kind of work which was being done. So Pranav, can you give me the direct link for that world map kind of
World data.
world data?
So if you type on Google world data, you might get the link there itself.
Absolutely, absolutely. I'll just type in world data. So which is very impressive, and I believe all the people, those who are working in this section, would be very happy to see that.
So we are having virtually data for everything stored in world data. Yes, that is world data. Yeah, go on there.
Right, I'm just opening that.
So from temperature, currency, stock markets, environment pollution, every data is available on this platform.
Right. So Pranav, where should I go? Should I click on this?
Uh, you can like if you want to have global like you can
Yeah,
explore this.
I can explore this. I actually want to see that, that interface, which was the live interactive, like a graphical interface.
So that interface is something that we keep private to clients. You can see the data from here.
Okay, okay. But I don't know why, but I have seen that somewhere.
Okay.
Okay. Okay, let me just check. So, okay, anyways, what I'll do, I'll check that, because that was very impressive, and I will be sharing that information with the students also about how this kind of things are done in the industry. So coming to the final closer of the program. So thank you again, Pranav, for bringing a lot of insights of data science to the platform. And we will be organizing this program shortly with the students so that they can learn. The students will be of different categories. They might be undergraduates, they might be postgraduates doing their research into some segments. So it's a mixed audience which will be learning in the platform, and I'll be sharing that information further with you. So thank you so much.
Sure, no problem. And guys, all the best for your career. I think you are having a really good option for having data science as your career field. It is a really blooming field. A lot of job markets are opening up even in this COVID-19 pandemic. So the choice is good. Okay, so don't worry about that part at this point in your career. And I wish you all the best. Thank you for attending the presentation part and see you later, guys. Bye. Bye, Marshu.
Bye.
Thank you, sir.
Thank you, Pranav. Thank you.
Thank you, guys. Bye.
Bye. Take care.
Bye.
Thank you, guys. Thank you so much for attending.